Okay, so this time we really need to pay attention to what information we've been given and what we're being asked for. Here we're being asked to find the measure of angle A. When you're looking for an angle measure, you have a right angle with two sides, you're using your inverse trig function. So we're going to set it up pretty much exactly the same way as we set up our trig functions, our trig ratios last class. We still want to circle the angle that we're dealing with, which is angle A. And we want to label the sides that we have as they relate to angle A. So this is my opposite because it's across from angle A. And this is my hypotenuse because it is across from the right angle. And then we review our trig functions, which trig function has an O and an H in it. And that would be sine, an O and an H. Now before we would just set up the sine of your angle equals opposite side over hypotenuse, but since we're finding an angle, a missing angle, we do the sine inverse. Just like you have the superscript here of a -1, just like you have, if you have 30 degrees, you have the symbol for degrees. It sits above the number. This should remind you that when you're looking for an angle, you use the -1 for the sine function. So the inverse sine function of your opposite side over your hypotenuse is going to equal your missing angle. So then we fill in everything. Your sine inverse of opposite side over hypotenuse, so 18 over 27 equals your angle. In this case, we're looking for angle A. And now we just use our calculator. And I'm really excited today because I found out how to change the color of my calculator and I wanted it to be blue. Yep. So we double check to make sure that we're in degree mode. That's here under mode and then degree. Go ahead and exit out of there. Second mode quits you out of there. And we just type in exactly what we see here and it'll give us angle A. So to get the inverse function, that's above the sine. So right here, sine -1. So you press second sine, you see sine -1 of 18 over 27. And that will give you your angle measure. So the measure of angle A. Now, here's the other tricky part. It really doesn't matter if you round to the nearest tenths or whole number, but for our purposes, we're going to round angle measures to the nearest whole angle. So instead of 41.8 degrees, we're going to take this to 42 degrees. So that gives us the measure of angle A. And the reason we do 42 instead of 41.8 is because you don't usually do or see decimals when you're using angle measures. These are usually represented as the nearest whole number. So I would like for you to try the next example. Find the measure of angle B. So again, circle the angle, label the sides as they relate to angle B, and then set up your inverse trig function because angle B is a missing angle. So pause the video and see if you get the same answer as me. Okay, and you should get that the measure of angle B is 11.5 degrees or 12 degrees. Either answer is acceptable. If you did not get this answer, please raise your hand and one of us will come over and help you. Okay, so those both involved using the sine function. Now we're just going to do another example looking for the measure of angle A. So again, since I'm looking for A, I'm going to be using the inverse function. So whatever this trig function is raised to the -1 power. And I label my sides as they relate to angle A. The hypotenuse is over here. We're not using the hypotenuse, but I like to label it just because it keeps me from getting the hypotenuse and the adjacent side confused. Because both 20 and this side, the hypotenuse, are touching angle A. So they're both technically adjacent to, meaning next to angle A, but the hypotenuse already has a name. It's called the hypotenuse and it's across from the right angle. So 20 is the adjacent side, side AC. And BC is across from or opposite of angle A. So going back to my trig functions, so ka TOA I am going to use the tangent function. O and A, O and A. So I'm using the tangent function, but because I'm looking for an angle measure, I use the inverse tangent function. And I set it up exactly as I set up the tangent function, except that the ratio will be right next to the inverse. Tangent is equal to the opposite side over the adjacent, and the inverse will give me the measure of angle A. So now I set up my ratio, tangent inverse, opposite, which is 6, over adjacent, which is 20, will equal the measure of angle A. And let me get out my calculator here. Blue, nice and pretty. And I'm going to do second tangent of exactly what you see typed here, or written here. 6 divided by 20. And that will give me 16.699, which I can round to 16.7 or 17 degrees. So the measure of angle A, I'm going to say 17 degrees. Okay, now at this point, if we have a right triangle and any two pieces of information, we should be able to solve for any angle or any side that's missing, as long as we're given two pieces of information other than the right angle. So in this example, we want to find the measure of angle x, find the measure of z, and then find yz. So we should be able to find all sides and angles of this right triangle. Now, you have to do it one step at a time. So one problem at a time. Treat this as three separate problems. This will be problem number 1, this will be number 2, and this will be number 3. So let's do number 1. Number 1 is asking us to find x, which is a missing angle in a right triangle given two sides. So that means that I'm going to use the inverse trig function. So I'm just going to put a little -1 power here to remind me. So I label the sides as they relate to x. This, of course, is the hypotenuse. It's across from the 90-degree angle, and this would be the adjacent side. So I have an a and an h. That means I'm using the cosine function. And because I'm looking for a missing angle, I do cosine inverse. And cosine inverse equals adjacent over hypotenuse, or 15 over 25, and that will give me my missing angle, angle x. So then I get my calculator out. Whoa, it's pink. How awesome. Get my calculator out, and I'm going to do the second cosine of 15 over 25. And that will give me the measure of angle x. I'm going to round that to 53 degrees. So the measure of angle x equals 53 degrees. I'm going to put that here. And I'm going to erase this a, this circle, and this h. The second question said to find the measure of angle z. And this time, I don't need to use any trig because now I have 1, 2 out of 3 angles in a triangle. So I can find the third angle by using the triangle sum theorem. If I've already used 90 degrees, that means of the 180 degrees possible, so I would subtract 90 and 53. Look at that orange. How exciting, all the colors. So I would take 180 degrees and I would subtract 90 and I would subtract 53, and that would give me 37. So subtract 90, subtract 53, and that gives me 37. So the measure of angle z is 37 degrees. And then for the last step, I'm looking for side YZ, given 1, 2 out of 3 sides of a right triangle. So that means I get to use Pythagorean theorem. So for step 3, I would do c squared equals a squared plus b squared, or I will call this b, the missing side. So c squared would be 25 squared, because that's the hypotenuse, equals a squared, 15 squared, plus b squared. 25 squared, no, it's still orange. 25 squared is 625. 15 squared is 225. And we're looking for our b. I would subtract 225 from both sides. So 625 minus 225 gives me 400. I'm going to come over here. So b squared equals 400. And now I want to undo the square here. I have to square root both sides. So I take the square root of 400 and I'm going to get 20. So b equals 20, which is side y, z. Alright, so all of that we can do because this is a right triangle, and a right triangle holds special relationships with their legs and their hypotenuse. I want you to try this last example on your own. Same exactly way we would do the previous example, or we did the previous example. I want you to find x, z, and side xy. You should pause the video and make sure you get the same answers as me. Okay, you should have gotten the measure of angle z is 44 degrees, x is 46 degrees, and xy is 9.8. And that is to the nearest tens place. If you did not get any of those answers, please raise your hand and let one of us know.